Three, your students are going to be creating a stop motion animation to show the actual motion of the 4MMS spacecraft relative to the position of the Earth. There's going to be a couple of different intended purposes for this activity. The first of which is to teach them how to find data on the MMS data site by changing certain variables that are date and time. The second reason is to be able to tell the story and teaching students how to tell the story using visual representations, and in this case a stop motion animation. So the tool that I'm going to be using is completely web-based. It's going to allow me to create my video for the first time. What you will notice here is I already have all of my images that students create and download in steps 6 through 8 in the actual activity. I already have them preloaded into here. Now I'm going to change the view, and again I'm showing you using a tool. This tool is called WeVideo, but you actually could be using iMovie, Windows Movie Maker, pretty much any tool that you would like. You'll notice that each of these incrementally increases by a 1 hour time frame, as your students were told in their actual directions. So down in video 1, I'm going to go ahead and I'm going to place each of these down there, and I'll start by just dragging them down one at a time. You probably could drag them multiples at a time, but I like doing it this way so that we make sure that we get them absolutely in the right order, because obviously stop motion animation is not going to work all that well if we don't actually sequence them in the order of the succession of the files. So in this particular case, I'm just going to go ahead and finish up here. And the other piece that students were asked, or they were told to do, was to actually annotate each of the files or each of the frames that evidence the motion. So this can be done one of two ways. In this particular tool, we can actually add text annotations like an arrow call out, or an arrow or a pointer call out. In this case, I'm going to use an arrow call out, and I'm actually going to drag that down. Now, before I actually do that, what I do want to do, because stop motion animation is only really effective if you are able to sequence those frames in a relatively fast pattern. If I right click after selecting all of my images and say adjust duration, I'm going to change that to 1 second. Now if you know a lot about making movies, you know you can actually change it to frames as well, but I'm just going to keep it to seconds, and you'll notice that shrinks that up a bit. Now I'm going to change the view of this a bit. It did not make the length of each of those any longer. They are still only 1 second, but that is like the zoom mode. Now I'm going to go ahead and I'm going to bring down my arrow call out, and I'm going to make the duration of that actually be a little bit less. So the first thing I need to do is I need to identify what the actual location of that was. Now I happen to know that it was about to -20 for my position, and this is where I can now go in and change in this particular tool, I can change the color, I can change the font, I can do all of those things. I'm just going to go ahead and I'm going to move that right to about there. Okay, so that's good enough. So now I have it positioned, or I have it designed the way that I want. Notice what I did there. I was able to simply drag that and bring that down through. Now I want to make sure, looks like I moved that a bit. I can simply double click, move that down, there we go, and now I can say done editing. So now I can go ahead and press play, and you'll notice that obviously if I would have added the annotations to every single one of those frames, you would have seen the coordinates actually populate as I was going all the way around. And so if we get to the end, you'll see that obviously it would have made one full succession if we would have actually completed that process. So one of the things that is also evidence to tell, I should have checked this, because as you can see, it actually is more like -17. So what's great about this activity is that you'd be able to talk to your students and say, now how did you determine it was 2 -20? Because clearly it's actually about 2 -17. Now you could actually, if you have an image editing tool that your students might use, like GIMP or Photoshop, or even Microsoft Word, that they can then export from Word as a JPEG file, your students could actually annotate over the images before they ever even import them into the movie. Then you don't even have to worry about adding that annotation over top of the movie as I did here. Because you notice this tool happens to have two video streams that I'm able to do one on top of the other. Not all tools have that. Finally, the last piece is that we may want to, and certainly your preference to this of what tool you use could dictate this as well, but you have your audio track that you would want to have students either pre-record or more likely than not add a narration that while the video is playing they can actually be narrating and talking over top of that to describe exactly what is going on as the orbit of the spacecraft progresses around the Earth. Finally, the last image, which I don't have represented here, but the last image that was as part of the activity was to go one full orbit into the future and make a prediction. Remember, predicting after using data is the analysis piece that we want to get our students to be able to do. So if you think about having your students go one full orbit, if it takes more than one full Earth day to be able to actually orbit the Earth by one of the four spacecraft, what will be interesting is to see whether or not when they make their prediction, that if it's, say, instead of 24 hours, it takes 29 hours or 33 hours for the four spacecraft to completely orbit the Earth, then if they go ahead 33 more hours, is or are the coordinates of that spacecraft exactly the same as what they were or relatively close to what they were? And if they are a little bit behind or a little bit ahead of where the spacecraft was, you would want to, as you're listening to how the students are describing that, determine what the students' rationale or reasoning might be that they're explaining why they think that might have happened. And because the spacecraft are controlled by NASA scientists and they have their own ability to control their orientation relative to one another, maybe that could have impacted the rate of orbit, but maybe not. So those are the things you would want to hear your students talking about is, are the orbits impacted at all, and what could possibly be causing that if they don't follow the exact same duration of time. So hopefully this gives you at least a little better idea of how to create that stop motion animation, adding the data over top to make sure students are understanding the coordinate plane, and then obviously being able to explain and describe the predictions they made about where certain spacecraft should be based upon the activity that they were conducting.